Hello. There are different diverse organisms on Earth, and they all have different types of genes, and they have different types of introns. And in that sense, the way the introns are eliminated and exons are spliced could be different as well. And now we'll have a look at the different types of introns and their specific splicing mechanisms. We'll try to see in the way they are similar and the way they are different. That will make it easier for us to remember it for a longer time. So there are three different types of splicing machineries that we know of. One of it is the pre-mRNA spliceosome that's given here. And the second one is called as group 2 self-splicing, and the third is called as group 1 self-splicing. As the terms indicate, group 2 and group 1 introns are self-splicing. They do not need additional factors to carry out these transesterification reactions. Whereas in the pre-mRNA ones, they require special or additional components which are called as spliceosomes. So in that way, group 2 and group 1 are similar, that they do not need additional factors, whereas pre-mRNA spliceosome introns will require these factors. And if we see the difference between or similarities between pre-mRNA spliceosome and that of group 2, as we can notice is that the branch site A is same, or the mechanism of transesterification is similar, in the sense that the branch site A would get activated, the 2' OH of the branch site A would get activated, make a transesterification reaction here, thereby the 5' splice site is bound to the 2' OH now, forming a 3-way junction as depicted here. The same thing also happens in the pre-mRNA spliceosome ones. And the end product of these two, because of the way the chemistry or this transesterification happens, is the lariat in both the cases. So the similarities between the group 2 and pre-mRNA spliceosomes are very similar in terms of their chemistry, only that spliceosome requires an additional factor. Group 1 is interesting, and in that group 1 does not have a branch site A like in the cases of group 2 here. Instead, the group 1 intron folds upon itself, creating a microenvironment in which a GTP can be bound, and that GTP, the 3' OH of that GTP could get activated and will make the transesterification reaction here. So basically, the G that is non-covalently bound to the intronic region at that point would make an attack, or the 3' OH is activated, and then would make an attack on the 5' side of the intron and would get covalently linked there through ester bond. And the 3' OH of the exon here would create the second transesterification reaction, because of which we now have two introns spliced together, and we have the intron left out. And here the intron is a little bit different. The end product is a little bit different. If we compare to that of the group 2 end product, this is a lariat, whereas the one that is formed in the group 1 splicing is a linear one. Only difference though is that we have a G added here. So this is not like a G cap, because the linkage here is something like 3' to 5' linkage. Remember that we have the 3' OH that is getting activated and making a transesterification reaction with this. So we would have had a phosphate on the 5' side of this intron, which is now bound to 3' OH of the G. So that is quite normal, like the other linkages. In the G cap of the eukaryotic 5' mRNAs, we would have had 5' linkage, and there would have been 3 phosphates and not just 1 phosphate. That is another thing you can probably remember, how the G here in case of group 1 introns differs from that of 5' G cap of eukaryotic mRNAs. So in summary, spliceosomes are very common. There are numerous eukaryotes and all of them have introns, so they require this special spliceosome machinery to carry out these things, and they are very common. In all the cases, of course, the transesterification reactions, there are 2 of them in all the cases. That is the same thing. The common between spliceosome, one is that branch site adenine, and group 2 introns also have branch site adenine. Whereas in group 1 we have a GTP, and I don't think we should call it as branch site because it's not a part of the intron, but it forms something like a folding onto which GTP is bound non-covalently. These 2 can be referred to as ribozymes or RNA enzymes because they do not have they do not require additional components. But at the same time, enzyme is something that does not get consumed during the reaction, but here it does. So yet there are, because it is able to do it by itself, we can, at least for the sake of attributing something, we can call, at this stage, we can call them as RNA enzymes. We'll see you with more details in the later lectures. Thank you.